And we're recording for Gracie. Hey, Gracie.
Don't brush your legs.
Wow, what is
out of line.
Jinx, you owe me a Coke. All right. Here we go.
Wait.
Is this one on your YouTube
Our
channel?
horses are more healthy.
All right, so we have a common denominator. The common denominator we found is x minus 8, x plus 4, and x plus 2. We found that common denominator because they share an x plus 2, and x minus 8, x plus 4 are the extras, right? So what they share and the extras will always be your common denominator. All right, now the numerator. What was the original numerator times the factor that we gained? So, Lila, for that first fraction, what's the original numerator? X plus 1, good. And what factor did we gain? X plus 4, great job. All right, Merman.
I knew that was going to happen.
Yeah, you did.
X plus 1.
Yes, the original numerator is x plus 1. What factor did we gain?
Oh, shoot. Let me look.
Uh-huh.
Oh, shoot, I forgot my parentheses.
Brother.
I would have to say the x plus. I don't want to say the wrong thing because it's a little embarrassing. 4? No, it's
Already had an x plus 4.
X plus 2.
Already had an x plus 2.
X minus. I don't know.
The only other option.
X minus 8.
Take a look, dude. How many factors do you see here? 2. How many factors do you see here? Yeah.
Oh, I'm looking at the wrong side. Okay, that
What factor did we
the x
gain?
minus 8.
Yeah, exactly. That's it. Yep, we gained the x minus 8. X minus 8. Now, do you see what I'm saying? The original numerator times the factor that we gained.
I feel we can't put this on YouTube.
Oh, it's going up there. Yep. And I'm putting your name in the in the title. Yeah. Oh, absolutely. Here we go. All right, so now I'm going to go from 2 fractions to 1 fraction. We have our common denominator, x minus 8, times x plus 4, times x plus 2. Now this time I'm subtracting. So if you go back and think about adding polynomials, ignore the parentheses and combine like terms. But when we subtract polynomials, what did we have to do differently? Distribute the negative. So we're going to set this up so that we have polynomial minus a polynomial, because we will have to distribute the negative. So, multiplying my first pair of factors, we're going to FOIL it out. X times x gets us x squared. X times 4 is a positive 4x. 1 times x is a positive x. 1 times 4 is a positive 4. I do not need the parentheses around the first polynomial. However, when I go to subtract, I want to put the second polynomial in parentheses as a reminder that I will be distributing the negative. So when we FOIL this pair, x times x is x squared. X times negative 8 is a negative 8x. Extend. 1 times x is a positive x, and 1 times negative 8 is negative 8. All right, now I want to clean this up. I have my common denominator, x minus 8, x plus 4, x plus 2. I have this polynomial, so we're going to combine these like terms, 4x and x. So we have an x squared plus 5x plus 4. And before I distribute this negative, I'm going to save myself just a little bit of time. A negative 8x plus x is a negative 7x. So I'm going to combine my like terms there, and then distribute my negative here, here, and here. So we have a negative x squared Negative times negative 7x is a positive 7x. And the opposite of negative 8 is a positive 8.
Don't cross your legs.
They're not crossed. They're not even touching.
Get out of Dang, that attitude
You don't
today.
know me.
Well,
Bad day.
it's a great day. It's game day. Everything's great. I just got delivered some news that is making me very upset. I mean,
Sorry.
really, really upset.
I'm so sorry.
Yeah, I'll be fine.
I fear he may need the teardrop today.
No. When I get angry, I don't cry.
I angry.
You do ASMR in your wife's ear.
Yes, I do, sweetie. That's exactly.
Oh.
All over. X minus 8. X plus 4.
I didn't even know he was.
X plus 2.
Bigger fish to fry. I'm in a chair for a second grader.
All right, so combining our like terms, we have an x squared and a negative x squared. She go. 5x plus 7x is 12x's. 4 plus 8. Yeah, nice job, Lily Lewis. It's a 20. Biscuits. I was all celebrating you.
There you go. There you go. Now she's celebrating you.
If I factor out a 12, I'd be left with x plus 1. Would that cancel with anything down there?
No.
Nah. So we're done.
Samesies.
Gracie's at home like, guys, hurry up. Stop talking about it. Gracie Fanning.
She's the one with the...
Yeah, she asked me to
She's so
videotape the lecture so she'd have the notes when she got back. Yeah, she's playing softball in
What
California or
You
something.
said she got a big forehead. I thought I know her.
She's the one with the forehead.
No.
I'm just joking.
Oh my God, I hope she didn't hear that.
I hope she did.
Oh.
Basic.
Oh, Marie.
Fanning.
That's her middle name?
I have no idea.
Yes, you're right.
He said basic. It's a 5 head.
More like 6 head.
What about a second?
Bro, why would you say that?
Mr. Stevens, I did not say that.
It's
Yo, bro,
it's
stop. Just delete the recording.
it's giving. All right. All right, here we go. I'm going to do this problem. I think there's one similar to it in your homework, so I'm going to do this guy with you. My factors are 3 times x. My factors are 6 times x. My factors here are x times x. So when I set this up, something plus something minus something, what would our common denominator be? So what do they all three have in common? They all three have an x. Good. What are the leftovers?
Three, six.
Yeah, a 3, a 6, and another x.
Okay, then.
So we get a 3, a 6, x, and x, a 3, a 6, an x, and an x. Alright, so the original numerator, on my first fraction, the original numerator is 1. What factor did we gain? A 6 and... we already had a 3. And an x. So we gained 6 and an x. My second fraction, the original numerator is a 1 times. What factors did we gain?
3, 6.
A 3 and an x. And looking at that, bless you. Looking at the last fraction, the original numerator is a 1. Now what factors do we gain?
1.
A 3 and a 6. Now we can put this all over a common denominator. 3 times 6, I believe, is 18. X and x, I believe, is x squared. Alright, 1 times 6 times x is 6x. Plus 1 times 3 times x is 3x. Minus 1 times 3 times 6 is 18.
Can't you just simplify that to 9x?
I'm about to.
Okay.
9x minus 18. Great job. All over 18x squared.
And are we done?
I can't cancel just one. I'd have to do the whole thing. Yeah, but all three are divisible by 9, right? And so what that would look like, if I factor a 9 out of this, I'd have 9 times x minus 3. And if I factor a 9 away from him, I would have 9 times 2x squared.
Did you score really high on the ACP, the math section?
Dude, I failed college algebra 3 times, homie.
Really?
9 divided by 9 is 1, so I'm left with x minus 3 over 2x squared. It's a 2. I'm sorry. Sorry, she's a 2. Thank you, Jaden Emery Peters. Don't put my name on the internet. People are going to see it. Dude, only one person's going to watch this video, and it's Gracie Marie Fanning. All right?
With the 6 head.
No, it's just not all of
With,
emphasize that. Okay.
What did you emphasize?
The certainty numbers.
Mr. Stevens.
Yes, sir.
Do better.
Coming from you, Austin, that means a lot. All right.
Oh.
I will. Here we go. How do we handle these compound fractions? So, when it comes to compound fractions, our goal is to get ourselves
Keep change flip.
into a keep, change, flip situation. Yeah. So, I only can happen whenever I have a fraction over a fraction. Currently, I don't have that. I have a fraction plus a fraction over a fraction. So, what can we do in order to get ourselves into a fraction divided by a fraction? What do we need to do?
Something with a negative? No.
We're not here yet. And that's because when you were playing with hair and not listening, I said we need a fraction divided by a fraction. We don't have that. Currently, we have a fraction plus a fraction divided by a fraction. Philip, what are we going to do? No, I can't do that.
Can we factor
No, we're not going to factor.
someday?
Can we add fractions?
Yeah.
Yeah, let's add the fractions on top. And when we add those two fractions on top, we'll have a single fraction that will be divided by a single fraction. So, here's my scratch work.
You're so stupid.
Yeah, don't do that. You're okay. We have 1 over x plus 2 over x plus 1. Nobody in any other class answered that question, so don't feel bad.
Oh, okay.
Well, we could have been the first.
Yeah, you had a shot. I gave everybody equal opportunity. They're not touching you. Leave me alone. I don't even know you, child.
The ones they're not touching. Leave me alone.
All right, my common denominator.
X
Yeah.
plus,
Times.
times X plus 1.
Good. David, you can be better. X times x plus 1. Those are my two factors. We have x times x plus 1. All right, with that first fraction, Sully, what's my original numerator? 1. Good. What factor did we gain? From here to here, what factor did we gain? Not 1, that whole thing in parentheses. X plus 1. Good. All right, Sully, looking at the second fraction, what was the original numerator? Good. And what factor did we gain?
X plus 1.
Yeah, we already had an x plus 1.
So it's just 3.
What's the other thing? What's the other factor? Just an x. Good.
So it'd be 2x.
That's right. Now, all over one common denominator, x times x plus 1. 1 times x plus 1, I can ignore my parentheses because it's a positive 1. So, combining like terms, x plus 2x is 3x. 1 is a positive 1. So the numerator of our compound fraction is this guy right here. So instead of fraction plus a fraction, I now have one fraction. 3x plus 1 over x times x plus 1. That's my numerator. All over 1 over y. Not now, Austin.
Dang.
I'm sorry, Jim.
It's okay. I'm an attention whore. I want all of your attention. Don't give it to Lily. Yes?
Distribute the x squared plus x.
We could, but I want to leave it in factored form just in case it can cancel later on. Yep, that's a great question. Just in case. So I'm always going to leave everything factored as long as I possibly can. The only time I'm really going to be doing any multiplication is whenever I go from here to here with my numerator. Because I cannot combine these, that's my turn! Because I cannot combine them as fractions, I want to combine them after I FOIL them out. Great question. Really good question.
My pencil broke.
Do I now have a fraction divided by a fraction here? Yeah. So now we can keep, change, and flip. We're going to keep 3x plus 1 over x times x plus 1. We're going to change from division to multiplication. And we're going to flip. 1 over y becomes,
Y over 1.
that's right.
You're so funny.
Now we multiply straight across the top, across the bottom. We get y times 3x plus 1 over x times x plus 1. There we go. Nothing from the numerator will cancel with anything from the denominator. Y cannot cancel with x, and 3x plus 1 is not the exact same as x plus 1, so they cannot cancel. All right, I'm going to speed run one more of these things, complex fractions. I'm going to speed run one more of them, all right, see how that works, and then you got everything you need for your homework. All right, here we go. Well, I guess I can do both of these. We got time, yeah? 1:07, we go ham until 30. Yeah, we got 23 minutes. I can do this. All right. So I have a fraction divided by a fraction plus a fraction. So over here on my scratch work, I probably did not give myself enough room. Over here on my scratch work, I want to add these two fractions from the original denominator. So x plus 1 over 3 plus 4 over x minus 1. What factors am I going to have with my common denominator? And what's my other denominator? 3. Good. So we have 3 times x minus 1. And 3, yeah, isn't that what it was? Yeah, what are the two denominators? 3 and x minus 1. So we just multiply them out. All right, Chloe, let's talk about it. What was the original numerator of the first fraction?
X plus 1.
X plus 1, good. And what factor did we gain?
X minus 1.
Good. Oh, yeah. Yeah, here in a hot second we will. Yeah, good job. What was my original numerator for the second fraction, Chloe?
4.
Good. And what factor did we gain? From here to here. From here to here, what factor did we gain? 3. Good. Really, really good. Now I want to go from 2 fractions to 1 fraction over the common denominator. Oh, it's x minus 1. Boop. Okay. Now, x plus 1 times x minus 1. Jaden Emery Peters. Loud and clear. What do you notice about x plus 1 times x minus 1?
It's a perfect square.
It is. They are a conjugate pair that will multiply to perfect squares. So what is the result of multiplying x plus 1 and x minus 1?
X
Yep. Yeah, good. Right? A plus B, A minus B, A squared minus B squared, right? So, x squared minus 1. All right, and we're going to add 4 times 3, which is?
Well,
Those attending state rental today, please come to the office. Those attending state rental today, your attendance, please come to the office.
All right, so combining our like terms, yeah, we have our common denominator. Combining our like terms in the numerator, I only have 1x squared. Negative 1 plus 12 gets us what?
11.
A positive 11. Good. Was that the original numerator or the original denominator? At the complex fraction. Did this come from the top or the bottom? The bottom, right? This is what we just added, these two down here to get this guy. So, when I go to rewrite this, I have 1 over x minus 1, all being divided by x squared plus 11 over 3 times x minus 1. And now we get to keep, change, flip. Alright, so we keep the numerator the same, 1 over x minus 1. We change from division to multiplication, and we flip the bottom one. 3 times x minus 1 over x squared plus 11. Now, do you see anything?
Yes.
What?
The x minus 1.
Good job. The x minus 1 on top will cancel with the x minus 1 on bottom. So, what are we left with in the numerator?
Could you do that as 3?
1 and 3.
Because you multiply 1 and 3.
That's exactly right. 1 times 3 is? Yeah.
3 over x squared plus 11.
Great job. Yo, that's exactly right. Way to go, merman. It's merman. Sorry, I'm so sorry. If that bothers you, I really feel bad because it cracks me up. I am, but I don't want it to be at anybody's expense. I really don't.
Okay, I don't care.
Even though I throw a considerable amount of shade at all of my babies, I don't want anybody to get their feelings hurt. Okay. All right, let's try out part B. They're not even touching.
You don't know him.
So I have a whole number minus a fraction divided by a whole number plus a fraction. So we need to clean up the top and the bottom here. I have 2. What's 2 as a fraction? 2 over 1 minus 1 over x. I got to figure out what that's going to be. So what's the common denominator?
1x.
Just an x. Yeah, that's right. 1x. That's it. So my first fraction, what did I gain? I gained an x. So I start with my original and what I gained. So the original numerator was a 2 times the factor that we gained, which is x. All right, here. What did we gain for this guy?
1.
Nothing.
Oh, we already had an x to start with. What did I gain?
Net.
I gained nothing, right? So the original numerator here is just a 1. I've gained nothing. So now, combining like terms in the numerator, we get 2x minus 1 all over x. Now, we got to clean up the denominator. How do I turn x into a fraction?
X over 1.
X over 1, good. Plus 2 over x. What's our common denominator going to be? Just an x. And we have a plus and an x. So, my original numerator for the first fraction was x. What factor did we gain?
A 2.
We gained an x.
That was right. I was just guessing. I was locked in my writing.
You're good. All right. For the second fraction, the original numerator is, and what factor did we gain? Nothing. Good.
We have nothing.
So cleaning this up, easy. X times x is x squared plus 2 all over x. Now I can put these back into the original complex fraction. My numerator now is 2x minus 1 over x. all over my denominator is x squared plus 2 over x. Now I have a fraction divided by a fraction. We're allowed to keep, change, flip. So we keep 2x minus 1 over x. We change from division to multiplication. We flip. X squared plus 2 over x becomes x over x squared plus 2.
I want to say we can cancel the x's.
Yes, be confident in that. Anything from the numerator match exactly with something from the denominator. Them x's are gone. Bye, Felipe. And we're left with 2x minus 1 over x squared. Ooh, I am not saying that about you, Philip. I did not. Yeah.
Felipe.
Yeah, no, I've been saying that for years. Ever since Bye Felicia was a thing, I was like, what do we say for the guys? And then my sister-in-law later was like, it's Bye Felipe. And I was like, great. Felicia, Felipe, that's the only reason. Yeah, it had nothing to do with you. You just happened to back into that joke. Okay. Sorry, I'm a bit manic today. All right, any questions about adding, subtracting fractions? Rational expressions? We're okay. All right, the homework is posted due Monday.